We're on our second video of the human skeleton. We were just talking about the cartilage in between the vertebrae. We were looking at how large the lumbar vertebrae are. And the large lumbar vertebrae allow for the weight of the body, allow for us to be able to stand upright. And we were looking at the cartilage in there. The cartilage is a shock absorber as well as different parts of the bone. But the cartilage allows us to be able to move, allows us to be able to bend over. Now, as we look at this, okay, and we look at the coccyx or the tailbone, okay, all right, it's kind of interesting because we talk about this and the sacrum and the hips, and we'll talk about all of these things. And I want to put, the reason why I'm putting these videos in there early is I want you to see some of these things, and then as you learn about them, you're like, oh, I begin to see the function. But let's look at this. Let's look at this tailbone, okay? You know, if somebody were to say, you know, do we have a tail? And the answer is, you know, we really do. But this is the actual tail right here. But notice something interesting. It curves in. Okay, it curves in. Whereas other animals that have a tail, the tail curves out. And on most animals, the longer the tail, the more it's used for balance. A monkey has a long tail that balances out the weight of the front part of its body. So our tailbone, okay, believe it or not, is a little bit of a sensory for balance, but it's not totally due to balance. Once again, it's there to protect organs. So do we have a tail? Yes, okay. And it's kind of interesting because we also see a lot of whenever we have a hole, it's called a foramen, okay. So look at all the foramens we have here, all the holes, and we'll talk about what those are. That's, once again, critical because what I want to show you on the back of this is, so we have this spinal cord, and that's amazing, all right? And I told you earlier that we had all the cartilage in the front. But then I started to tell you that we don't really have a lot of cartilage in the back, that instead we have, and we'll talk about the terms for the spines, okay, the ends of the vertebrae, but what we have is fascinating. Because what happens is, as the spinal cord is in here, the nerves come out of these little openings. Isn't that amazing? This is where the nerves come out and go to the different parts of the body. So we have these small openings in here, okay? We have these small openings that allow the nerves to come out. So what we have in the back is all of the nerves coming out and then going to the different part of the body, okay? So the nerves come out of the back of the spinal cord. So that's pretty awesome. And how did they come out? They come out through these areas. So what could happen for a pinched nerve? All right, when we say we have a pinched nerve, there's lots of things that can happen. We have another nerve that runs right down our ulna, and it could get pinched right here. It could get pinched right between the humerus and the ulna. Okay, but we also have a serious problem when our back, okay, when this cartilage begins to wear out, okay, all right, or our back is not properly aligned. I know this is the whole business of a chiropractor. Is your back completely aligned? And I'm not here to talk about chiropractors or whatever. I will say this: a chiropractor is simply looking for the alignment of the back. And why is that important? Because the nerves come out. The chiropractor will know this nerve goes to any part of your body. If your leg is having trouble, then he knows where that nerve comes from. There's nerves that go to your spleen. There's nerves that go to different organs. There's all kinds of nerves. And a chiropractor or a regular doctor would know that. Now, the thing about a chiropractor is if there's other problems in a chiropractor, it goes beyond a chiropractor. Chiropractor is interested in the straightness of your back and to make sure the nerves are making connections. So if we had a pinched nerve, we could have a pinched nerve in our back, which means that these vertebrae have somehow closed this opening, or the nerve has slipped over outside of the opening. So when we talk about a pinched nerve in the back, that's what we're talking about. So we're like, wow, that's crazy. You know, I've got a pinched nerve. Well, once again, remember, don't overly think this. When we're just taking these classes, don't overthink it. But I want you to see when somebody talks about something, what's going to be happening. Now, the problem that a pinched nerve creates is, okay, is that once it's pinched, then we no longer send any message to and from the brain. remember how the nerves work. Remember, we have the motor neurons that send information through the spine and then to the motors. Remember, we have the sensory neurons, touch, taste, feel, and those nerves go up into the brain. And then remember, we have inner neurons that connect. And that's what we have throughout here. We have all these inner neurons. So now we're sending a message to the brain. So right here happens to be a particular nerve that goes to the spleen. So when we talk about the spleen, it doesn't even function right if you have a pinched nerve. So the back is fascinating, and I could say this like every other sentence, but we just can't take this human body for granted. I mean, and whether you believe in a creator or you don't believe in a creator, this is amazing. And man can't create these. We can make replacement parts, but even they don't work very good. So it's just amazing, the creator that created the human body. It's just absolutely amazing. But I wanted to show you that vertebrae is pretty amazing. I wanted to show you the tailbone as well. Now, let's turn around here and let's talk about in the hip, okay? And we'll talk about the three different parts of the hip when we talk about the body. But I want to show you this right here. This is this cartilage right here is fascinating because in the female, okay, when they talk about the female is so many centimeters dilated before she delivers the baby, what happens is it's an amazing deal because the body, when it's time for that baby to be born, this cartilage softens. And it literally is really tight, and that cartilage softens and allows this opening to open up large enough, okay? Allows this opening right here large enough, okay, for the baby's head to come through. Well, look at what else we've got. A little bit of a problem, don't we? See where we have this tailbone right here? Well, in delivery, it's amazing because then this tailbone separates out. Isn't that amazing? And makes an open canal for the baby's head to come through. And so what happens with this cartilage is there's a chemical in the body that begins to go. And that chemical then causes this cartilage to loosen up. And this, when we talk about so many centimeters dilated, we're talking about this area right here. So we say we're 5 centimeters or whatever. So isn't that fascinating? And then the other thing that's fascinating is once this is no longer has the catalyst, remember a catalyst is something that speeds up or slows down a chemical reaction. Once we no longer have that catalyst, then all of a sudden this cartilage tightens back up and goes back to normal. Isn't that amazing? So when we talk about the birth canal, we're talking about this cartilage here. We're talking about the reaction of the tailbone, okay? And then we're allowing for the baby's head to come out. So pretty fascinating there. Now let's talk about a couple more things, okay? Let's look at the arm here. Of course, we have this incredible ball and socket here. We have all the different things. We talk about tendons. We talk about ligaments. And when we talk about ligaments, we're talking about bone to bone. So major ligaments holding these in. Then when we talk about the hand, okay, and we look at the wrist, this is what's amazing. We've got a pesky fly in here. And so we look at all these little bones in the wrist. And why in the world, why, you know, I mean, once again, we didn't create the human body. God created this. So why not just have one bone to make it solid? Well, it's fascinating. Because in order to move this up, these bones have to move. But even more important, guess what's going through those bones? The nerves and the nerves and the circulatory parts that have to go to our fingers are actually in between those bones. Isn't that amazing? Isn't that amazing? So once again, when we move this with the nerve, we can move each phalange, each part of the phalange to move our fingers, move our toes. So I just wanted to show you all those little bones. I wanted to talk to you about the ligaments that connect bone to bone, and then the tendons that connect muscle and the organs together. So let's look at that. When we're talking about ligaments, this is a big one. Okay, this is a big one. So once again, we have our femur. Okay, we have our tibia and our fibula. And then we have our patella, we have our kneecap. So when we talk about the ACL, okay, the Achilles, okay, the Achilles is actually attached to this part of the humerus. Now this Achilles then comes across and goes all the way down and attaches to the back part of the ankle, okay, attaches to the tarsals. We have the tarsals and the metatarsals. Okay, so it kind of makes an X. So here it goes. So it comes across, attaches here, comes all the way down. Then this one comes here, goes here, and attaches all the way down. So what happens is we have this incredible bone called the patella. Now that patella, if we didn't have that patella and we didn't have this part of the lip here, whenever we kicked, we would actually probably kick ourselves in the head because our leg wouldn't stop. Okay? But what's amazing is this allows us to be able to walk. It's like a super heavy duty rubber band that gives us strength that whenever we push down on it, it'll actually allows for every action. There's an equal and opposite reaction. We have this incredible ligament in it, and part of it's a tendon coming up this bone, but we have our ACL. That allows us to jump. So when we bend our foot, what do? We stretch that rubber band there, and then boom, we go up. When we run and we move this, we stretch that Achilles. So what we do whenever we have a torn Achilles, we have an ACL injury, okay, then we have this, here we go, we have this big white ligament coming across here. Well, if it tears, okay, then what does that mean? That means that this bone is no longer connected to that bone. If we tear both sides, then we're not connected at all. Somebody that tears their ACL, okay, now you can strain your ACL, you can stretch it, and then your leg is not very tight to your knee. Somebody that tears their ACL, we go over and we move their leg, and we realize that their leg moves way too much. The leg moves higher up, the leg moves side to side because it doesn't have this strong connection. So we're hearing a lot of ACL injuries lately, and I just wanted to show you that, but that ACL that comes across here. So what do we do? If we tear this ACL? Okay, so what do we do if we tear this ACL? Well, then we come in, okay, and we come in and it's a wide section here, okay? So we come in and we cut the good one in half, and we take off half of this ligament, and we sew it. We put a screw in here, and we put a screw in here, and then we sew it to the other one. So now we have half of these. Why does it take so long to recover from an ACL? And why do they keep moving your foot? They keep moving your foot because movement causes that ligament, or that, the analogy would be a rubber band, to get stronger. But it also grows. So it can grow, and so that half a ligament will turn into a full ligament in a period of about 6 months. So when we talk about an ACL, I want you to realize that, and we'll talk about that a little bit more. So these are just a few things. On the skeleton. We just want to do a couple of videos here. There's so many more things we could go, but we're going to call it quits. And Seymour is just really glad to get to come out to the class. And Seymour, we appreciate it, and we've learned a lot, and we appreciate you. And what do you think of our class these days? Seymour says they're pretty cool. Thank you. Talk to you later.